There is an airplane flying cargo runs in Canada tonight, in weather that grounds newer aircraft that was built before the Second World War began. It has no digital cockpit, no fly-by-wire, no pressurized cabin. Its engines are the same basic design used to power fighters in 1938. By any reasonable measure of aviation progress, it should have been retired 3 or 4 generations of aircraft ago. Instead, it's still on the schedule. And here's the part that should stop you. Manufacturers have tried, again and again, for nearly 90 years to build the airplane that finally replaces it. Some of those replacements were faster, some were cheaper to build, some were, on paper, simply better airplanes. Almost all of them are gone now. The plane they were built to retire is not. So the question worth asking isn't what made the DC-3 good. It's a stranger, more specific question. What did the DC-3 have that made better not matter? To understand why nobody could replace it, you first have to understand something almost nobody expects. The DC-3 exists because of a plane it was never supposed to compete with. In 1933, Boeing built what should have been the answer, the 247, the first truly modern airliner, all metal, faster, safer. It should have ended the conversation before it started. Instead, it created an opening. Boeing's own airline, United, took the first 100 off the production line. Every other airline in America was told to wait. One of those airlines was American Airlines. Locked out of the best aircraft in the sky, they didn't wait. They walked across the industry to a smaller manufacturer and asked for something better than the plane they couldn't buy. That single act of corporate gatekeeping, not a technical breakthrough, is the reason Douglas Aircraft got the phone call that started all of this. What came out of that call wasn't just a plane. It was an answer to a question nobody had solved yet. How do you make an airliner that makes money by itself, without a subsidy, without an air-mail contract, purely by carrying people? Here's the twist almost nobody knows. The DC-3 wasn't even the plan. Douglas had already built its answer, the DC-2, and it was working. Airlines were buying it in 1934. If the story stopped there, you'd never have heard of the DC-3 at all. Then American Airlines' Cyrus Smith asked for something strange. Not a faster plane, but a wider one, with sleeping berths, so passengers could fly coast to coast overnight instead of taking a train. Douglas's chief engineer, Arthur Raymond, pushed back. Widening the fuselage meant re-engineering almost the entire aircraft for a feature nobody was sure passengers even wanted. They built it anyway. And then something happened that nobody in the room had planned for. Airlines looked at that wider fuselage, built for beds, and realized it could just as easily hold 7 more seats, 21 instead of 14. Same fuel burn, same crew, same operating cost. The sleeper cabin nobody was sure they needed accidentally solved the one problem that mattered: how to make an airliner profitable without a government check. This is where most documentaries would stop and call the DC-3 a triumph. But the interesting part of this story isn't that it succeeded, it's how completely it succeeded, and how quickly that success became a trap for everyone who tried to follow it. By 1939, DC-3s were carrying 90% of the world's airline passengers. Not 90% of American passengers, 90% of everyone flying commercially anywhere on Earth. Think about what that number actually means. It means that for a period of years, if you wanted to fly on an airplane on almost any continent, you were very likely getting on the same aircraft type. No manufacturer since, not Boeing, not Airbus, not anyone, has ever come close to that level of market dominance with a single model. Picture the Douglas plant in Santa Monica during those years. Fuselages moving down the line almost around the clock, riveters working double shifts, and aircraft rolling off the assembly floor faster than most factories could build a truck. For the first time, ordinary passengers, not just the wealthy, not just male, were boarding in numbers large enough that airlines could see, for the first time, what a business built on paying customers actually looked like. And the war that followed made the number even stranger. Douglas built over 16,000 military versions, the C-47, for the war effort. When the war ended, thousands of them were sold off as surplus, often for a fraction of their production cost. Suddenly, the world had an enormous surplus of an aircraft that was already, before the war, the most successful airliner ever built. This is the moment the trap closes. Any manufacturer designing a DC-3 replacement in the late 1940s wasn't just competing with a good airplane, they were competing with thousands of nearly free ones. Here is the first real crack in the mystery, and it's a strange one.
If you're enjoying this documentary, consider subscribing. Every video here is carefully researched to bring you the real stories, remarkable aircraft, and pivotal moments that shaped aviation history. Now, let's continue.
The DC-3 didn't survive because it was the best solution to the problem of flying passengers. It survived because it solved a completely different problem almost by accident, the problem of never needing to be repaired by a specialist. Picture a DC-3 on a gravel strip in northern Alaska, engine cowling open, temperature well below freezing, no hangar in sight, a mechanic working outdoors with hand tools, no factory technician on the phone, no parts warehouse for 1,000 miles. That scene, repeated for decades on airstrips from the Pacific Islands to the Amazon, is where the real story of the DC-3 was actually written, not in a boardroom and not on a brochure. The aircraft had been engineered almost as an afterthought to be simple enough that a competent mechanic could diagnose most failures without factory support. Its landing gear was famously overbuilt, able to absorb the kind of rough, unimproved runway that would have bent the gear on a more delicate design. None of that impressed anyone in 1936. Nobody put "easy to fix in a snowstorm" on a sales poster. But it meant that 20, 30, 40 years later, when an airline needed an aircraft that could survive a grass runway, freezing temperatures, and a mechanic with a limited toolkit, the DC-3 was often the only realistic option left standing. And this is where the engineers who tried to replace the DC-3 made their first mistake. Every candidate that followed was designed to solve the problem the DC-3 was famous for, carrying passengers economically. Almost none of them were designed to solve the problem that actually kept it alive, surviving decades of hard use, far from any factory support, with no acceptable substitute. That misunderstanding is the reason the "replace the DC-3" story is really a story of repeated, expensive failure, and almost nobody talks about it that way. Convair tried with the 240, pressurized, faster, built with American Airlines' own input on what should come next. Martin tried with the 202. De Havilland's tried from the other side of the Atlantic. Each one, on a spec sheet, looked like exactly what should have ended the DC-3's career. Better range, better speed, better comfort, the kind of numbers Douglas engineers would have envied back in 1935. And on the routes that actually mattered, short hops into rough, marginal airstrips where an airline's survival depended on the plane surviving abuse, not impressing passengers, almost none of them could push the DC-3 out. Ask a pilot who flew both, and the reason gets simple fast. A pressurized cabin means nothing on a strip that's just gravel and mud. Extra speed means nothing when the nearest qualified mechanic is 400 miles away and your factory-built cabin pressurization system just failed. Every improvement engineered for passenger comfort was quietly a liability for survival in the places DC-3s still worked. So operators kept making a choice that looked backward on paper and was completely rational on the ground. Keep flying the older plane you can fix yourself instead of the newer one you can't. There's a version of this story where the DC-3 is simply a rugged workhorse and nothing more. But that undersells what actually happened next, because the aircraft didn't just survive. It got modified into forms Douglas never designed. Look at a Basler BT-67 on the ramp today, a DC-3 airframe pulled apart, stretched, and fitted with modern turboprop engines and a new cockpit, and it barely resembles the original on paper. It flies faster, higher, and burns less fuel than the DC-3 that rolled off the Santa Monica line in 1935. And yet, the landing gear underneath it, the fuselage around it, and the maintenance simplicity that made the whole airplane worth keeping alive are still, unmistakably, the DC-3s. In effect, operators did something no single replacement aircraft ever managed. They identified the one part of the DC-3 that actually needed updating, and updated only that. This is the detail that should genuinely surprise you. The aircraft that nobody could replace was, in a sense, quietly replacing itself piece by piece for decades, while remaining technically and legally the same airplane on the registry. No competitor could do this because no competitor's business model depended on a 50-year service life in the first place. They were built to be sold once, not to be endlessly rebuilt by the very operators who owned them. By the 1970s, something strange had happened inside multiple manufacturers, separately, without any of them coordinating. They'd all quietly concluded there was no way to build a new DC-3 replacement and make money doing it. Here's why. A brand new aircraft has to earn back everything it cost to design, years of engineering, testing, certification, before a single unit turns a profit. A DC-3, by 1970, had already paid that bill, decades ago, to a different airline, in a different era, in a war that was already history. Picture that choice from an airline executive side of the desk, a proposal for a brand new twin backed by impressive projections sitting next to a 40-year-old DC-3 already sitting on the ramp, already paid for, already flying. One requires years of financing and faith in projections that might not hold. The other requires signing a check for spare parts. It isn't hard to guess which one a cautious operator chooses. So the choice facing a cargo operator wasn't really old plane versus new plane. It was finance an entire aircraft program's debt from scratch, or buy a 40-year-old airframe already free and clear and fix it yourself with parts that exist in every corner of the world. That's the part most retellings of the story quietly skip. The DC-3 wasn't outcompeting new designs on capability. It was outcompeting them on the fact that its bill had already been paid. Every new aircraft starts its life owing money. The DC-3, by the time anyone seriously tried to replace it, didn't. And this is where the final piece of the mystery falls into place, the piece that explains why this was never really a story about an airplane at all. The DC-3 wasn't hard to replace because Douglas built something aerodynamically perfect. It wasn't. Later aircraft flew faster, climbed higher, burned less fuel per seat, and carried passengers in far more comfort. In almost every technical category, the DC-3 was eventually thoroughly outdone. What no successor could touch was something none of them were designed to compete on. An airframe simple enough to fix without a specialist, tough enough to survive terrain nothing else could land on, and handed to the world in such enormous, nearly free surplus that no new design could ever match its cost of staying airborne. Nobody replaced the DC-3 in the end because nobody was actually competing with an airplane. They were competing with a moment, a wartime surplus, a rebuilding world hungry for cheap capacity, and a design simple enough that any mechanic anywhere could keep it alive without ever calling the factory. That moment happened once. It is very unlikely to happen again. Which is why, somewhere tonight, in weather that would ground a modern jet, on a runway a modern jet would refuse to land on, that same airplane is still doing the job it was never supposed to still be doing. Not the best airplane ever built, just the one nobody ever managed to make obsolete.